Live. We're live. Or are we? I have no idea. Greetings, Beltaloda. There we go. We are live. Hey, everybody. How's it going? I hope you're all doing very well. I am doing very well. That's it. Good. Audio and video is working. I never know. Like, man, technology sucks. It could just betray you at the last second. And so it's always good to know that everything is working. Okay, groovy. All right, so for those of you who are wondering what it is that you have stumbled into, this is going to be the live question show. Where you're going to ask me a bunch of questions about space and or astronomy, and I'm going to try to answer them live. So that said, a few ground rules. First up, we need the... I don't think any of the moderators are here. Okay, let's try the backup now. Let's see if that works. Sync is a little off. I don't have a solution for the sync. Are people seeing the sync being off as well? Let me know about that. Major internet outages. Yeah, I noticed. I was trying to browse Reddit this morning, and the regular subpages worked fine, but you go to the popular tab and it just said you broke Reddit, which is a very passive-aggressive error on their part, where you just feel sad that you did something. Like yours was the click that broke the camel's back. But yeah, the whole internet has been having all kinds of problems thanks to big problems with AWS. Now, I don't use AWS for any of my hosting, so I haven't really noticed any problems today at all, but yeah, everything seems to be okay. So hopefully one of the moderators are going to show up, but if not, hopefully our backup AI moderator is going to be able to grab the questions. And if that doesn't work, then I'm just going to talk directly with the chat. So we will scale gracefully no matter what happens here. Right. So just the ground rules here. This takes about 2 hours long. So we'll go from now until about 7 o'clock, but we'll see how much energy I have. Maybe it'll go longer. I don't know. My wife's on a trip, and so I don't have to like rush out and watch John Oliver with her. Now I can, we can chat all night. But until I get hungry. I forgot to eat dinner before I started. Anyway, yeah, so if you have never asked a question before, I will try to give more emphasis to the people who've never had a question answered before. Now, keep in mind that I am a journalist, not a scientist. And so if you ask me questions about my opinion about various scientific matters, I do not have an opinion. I can provide the scientific consensus. And if that excites you, then you're in the right channel, right? If you're like, yeah, I want to know what 98% of scientists agree upon, as opposed to hearing that scientists agree on something is anathema to you, then this is not the right channel. You want the one where we really try to focus on the science here. So, and then the third thing is we get a lot of the same questions over and over again. And I'll be honest, I ranted about this I think at the end of the Space Bites this week, where I was sort of like, someone was asking me, are we just the 3i channel now? And I'm kind of sick of dealing with trolls and science people who are like literally making stuff up. So I'm kind of done with that. Like, I feel like I've made my peace, right? I've said my bit, and now we're going to move on to the actual science of this thing. And so if there's non-science of this thing, I'm just going to ignore it from pretty much here on out. So I hope you're okay with that. Now, you can still trigger a rant about anything at all times. You just have to, whatever the right code words are to get me to rant, you just need to unlock them. But I'm probably done ranting about 3i Atlas. So, but I will still talk about the science of 3i Atlas. Absolutely. I'm just, not going to rant about the AI slot problem on YouTube and how if you do a search for comets, you just get page after page of nonsense. I reported a channel that's impersonating Michio Kaku. They're literally AI impersonating him with his face and his voice and getting him to just say nonsense about 3AI. Okay, I'm done. It's over. We're just gonna chill. We're just gonna relax, and we're gonna talk about space. That's what's happening today. Right. Let me start the recordings. 5 hours. Okay. This is the lighting, Chad. There's this one. And this one. Okay. Let's go to live. Is that chocolate for Fraser's dinner? Do you answer questions about the Earth? Curious to know if we're losing or gaining mass overall. That's a great question. It's about a wash. So we're gaining about 100 tons a day from space dust falling into the Earth. Old crumbled up asteroids. It just rains down. And then we're losing about the same of our atmosphere because of its interactions with the solar wind. I forget, one of those is more. I think we're losing mass more than we're gaining it. But not that it's going to make any big difference, and we're not going to lose our atmosphere over a long period of time. Let's find out. Hold on, Chad. Let's just see how it goes. I haven't brought the questions up yet. Okay. It is definitely slower. Let me just check. Yeah, you need to go back to 4.0 mini. That would be great. Yeah. So it took about 5 seconds for it to bring up the new question when before it was pretty much instantaneous. Okay. Sorry. Just chatting with the programmer here. Okay. Old timer. I've been watching a lot of old interviews with Isaac Asimov. Fraser, do you appreciate any of his literature? Absolutely. Isaac Asimov, I have a lot of foundational, most influential science fiction authors. And a big part of that was just when I discovered science fiction. So I was born in the 70s. And when I grew up, both of my parents were actually quite into science fiction. And so they had just the best home library sitting there. And it had Heinlein, Niven. My dad was really a big fan of Niven. And then a bunch of Isaac Asimov books and Ray Bradbury. So I had these classic science fiction stories from their youth just sitting there on this bookshelf. And when I was sort of at the right age and I was starting to read, and I was really starting to get into science fiction. I really liked Star Trek, and I was starting to get into astronomy. I was probably maybe 11 or so. And then in my high school, my teacher, and oh my God, I'm thinking about this for the first time. I've never talked about this before. So when I was in elementary school, in grade 6, my teacher, my English, or my teacher, at that point, you one teacher for all your classes, gave us as our reading assignment, Have Spacesuit Will Travel. And it's a science fiction, but it's a kid's science fiction book written by Robert Heinlein. And I read the book, and it was just great. Adventure, rocketing around the solar system, lots of danger. And it was for my young mind, it was fantastic. And then I finished that. And then I like came to my dad and I said, I really enjoyed this. I see you've got Heinlein's on the bookshelf. Tell me more. And so he recommended a couple of the books that were in his library that were sort of like the next level. So I read a bunch of Heinlein. There were tougher Heinleins, and then kind of moved on from there, read Larry Niven, really enjoyed those, and then moved on to Isaac Asimov. And, I read the Robot series. I read some of his like nonfiction books. He wrote just amazing science books. And eventually I made it around to the Foundation books. And for me, they were life-changing. Like I had already watched Star Wars as, when I was 6 or whatever. And I had watched a ton of Star Trek. But when you read Foundation, you get it. Like you get where they were all coming from. Like he wrote the sort of proto space opera, and that all of those other shows were kind of adapt. Dune, I read Dune. I read all the Dune books as I was going through high school. But I would say it was like Heinlein, Bradbury, Asimov, Niven were kind of like this core group of sci-fi authors. But then I read, oh man, like I took track, like one summer, I think I must have read 40 or 50 science fiction books in between school. So yeah, I was really into it, and Asimov was a big influence on me, and still is. Like I still go back and reread a lot of my Asimov books every couple of years. And I mentioned this in a previous episode. I went and reread my Zelazny books, which were also really influential to me. And like, there's a bit of a meme that the best science fiction was written from the 1960s to the 1980s. And I really want to fight against that, because there's a lot of newer science fiction that's terrific, but there is so much good science fiction written back then when the authors were starting to figure out these big ideas, trying to understand the consequences of alien contact, of faster than light travel, of dealing with relativistic velocity, of the future changing on a society that is unprepared for it. And a lot of those things that are just tropes today in science fiction, they were all figured out back between the 60s and the 80s. So if you haven't, go back and read some of those sci-fi books from back then. Yeah, Asimov was a treasure. Yeah, I did read the Lucky Star series. Yes, I don't remember anything about it though. That was... Yeah, it was by Isaac Asimov. Yeah, his kids' books. Yeah, I think I read one. Huh. That's a good question. Oh, and I use one of Isaac Asimov's quotes quite a bit, which is that, and I forget the exact way this goes, but the gist being that the science isn't sort of defined when people say the word eureka. It moves forward when people go, huh, that's funny. Steve Collins, how is Comet Lemon looking? I have no idea. I've had cloudy nights for the last week, which is sort of when, like right now, it's starting to move up in the sky. And so I'm ready. And each night I go out and go, nope. Maybe there's a few sucker holes. I can try and get a picture of it. But as soon as I can, I'm going to take some shots of it. King Tad 1136. If you had to bet, and ignoring Vera Rubin, which instrument do you think is most likely to find 4i? What kind of question is that? Like, ignore Vera Rubin, ignore the machine that is perfectly designed to find interstellar objects and is likely to find a dozen of them every year. Like Atlas, I guess, which is the precursor to Vera Rubin. No, it's going to be Vera Rubin. How can I ignore Vera Rubin? Vera Rubin's going to find all the interstellar objects from here on out, except for the occasional other one. Hooves. If galaxies are drawn to each other, why weren't galaxies gravity bound in the early universe like local galaxies today, when everything was much closer together? Gravity should have been stronger. So the universe that we find ourselves in today is the result of all of the various forces that are operating on the universe. If you sort of roll the clock backwards, then you sort of, everything is going in reverse. All of this expansion is going in reverse. And so the galaxies are closer together, and they're closer together and closer together. And eventually there are no galaxies. There's just the material for forming stars. And so really the question you're kind of asking is like, why didn't it all just glom up into like one big chunk? And so the answer is just that the momentum left over from the Big Bang was going to tear the universe, like tear the mass away from each other more quickly than the gravity could pull it all together. And the result that you get is that wherever there was more of a density of matter, that pulled in more material. And wherever there was less of a density material, then that caused these voids to open up in between these large-scale galactic structures. And if you look out at the universe today, if you look at the large-scale structure of the universe, you get these galaxy walls, these huge clusters of galaxies. They're arranged in these long structures that are, in some cases, billions of light years long. And then you have these giant voids. And over time, as the universe continues to get less dense, these voids grow. The places where material is pulling together gets more and more dense. But at the same time, we've got this process of dark energy that is accelerating the expansion of the universe. We've got this process of dark energy that is accelerating the de-densification of the universe. And so places that should have drifted together, maybe, it's about 5 million light years away. Like if you get about 5 million light years away, then, or if you get within about 5 billion light years of some other galaxy, then your mutual gravity is going to pull you together. But if you're more than that, then the expansive force of dark energy is going to push those galaxies apart faster than the gravity can pull them together. And so eventually, everything except that which is locally bound to us, Andromeda, the Triangulum Galaxy, a few hundred dwarf galaxies, that's all coming together into the future elliptical galaxy that we're going to become. Everything else is going to be drawn away from us and drawn away from each other. And so it's really just that the Big Bang had so much momentum that it just sheared all of that material apart faster than the gravity could pull it together. Ren BR, any news regarding Betelgeuse's companion star? I imagine that having a star orbiting near the outer envelope of a red giant may cause I imagine that having a star orbiting near the outer envelope of a red giant may cause interesting effects. So we covered Betelbuddy, which is this companion star to Betelgeuse, in this week's Space Bites, and we've covered it previously in a Space Bites, and then we covered the theorization that this thing exists in a previous Space Bite. So it's great to sort of watch this story unfold, and it will continue to unfold. Like now we know it's there, astronomers are going to be directing a lot of attention at it. And like what we know really is very little, except that it probably exists, although, there could be some image artifact that's just making it look like it exists, but maybe it doesn't. But where it exists, the orbit that it likely takes matches the sort of the dimming that Betelgeuse experiences. It takes about 6 years. It's about 2,000-ish days. And that matches this orbital period. In order to get that orbital period, this star has to be just outside the surface of Betelgeuse. And it probably has about the mass of the sun compared to Betelgeuse, which has about 16, 17 times the mass of the sun. But Betelgeuse pulsates, so it gets a little bit bigger and a little bit smaller and changes in its brightness and the amount of energy. It probably gives off fairly large sort of puffs of material that this star is having to go through. So, but Betelgeuse is gigantic, and the possible effect, but Betelgeuse is gigantic, so the possible effect that it's having is, very minimal, and this is the kind of thing that astronomers are going to have to track. So, we're going to keep on analyzing it. I'll keep reporting on what's going on. Uh-oh. See if I can reply to her. No, okay. I'm sorry to do this. My wife needs some technical support help, and I don't think she realizes what's going on. I'll be back in 1 second. Sorry to do this. Okay. Let's see. Because she's traveling. She's in. Okay, yeah. So whatever it is, she can wait 2 hours. Okay. The live stream times come as a surprise to her every week. Leave this in the edited episode. Wow, Fraser man, do you work out? Yes, I work out. It's either that or die. Syndrome. How do I begin introducing my 4.5-year-old to science fiction? Are there particular books or resources that you can recommend? I think with a 4.5-year-old, I would recommend more science fiction, like television shows and movies, like The Iron Giant. Maybe that's a little scary. But I mean, I think you need to let their interests be your guide. And when I was that age, I was more interested in dinosaurs and just space in general. And it wasn't about science fiction. It was about, I wanted to know about the reality. I had books that I loved to look at the pictures of the universe and space. And so, yeah. And so I think you just have to sort of help them, take them to the library and then sit down with different books and see what they like to look at, and then use that as a way to kind of follow and judge and guide. I mean, there's just I don't think you can, science fiction is great if that's what you're into. And most people are, right? If you go and ask a person what their favorite movies are, they're going to give you a list that largely contain science fiction movies, right? So, chances are 50-50 they're going to be into science fiction. And then your job is to just kick back. And chances are they're going to want to get into anime, science fiction, things you're not super into. But don't worry, they'll come around in the end. It's funny, my son is 21 now, and he's on a tear reading. And he's very much, okay, what's next? What's next? What do I read next? And so I've been feeding him all of my recommendations, and he's just been destroying them. And then he's giving me tons of recommendations because he's starting to really develop his own taste. So, he read a lot of more simple science fiction, like, Andy Weir. Sorry, Andy, but they're accessible, right? He read the We Are Legion, We Are Bob books. But then he's gone, he read Slaughterhouse-Five and is now reading Ian M. Banks and giving me feedback about the books as he reads them. And you can't force it, but you can absolutely be there and provide nuanced recommendations as a person goes down this journey of enjoying. Like, you can recommend the good stuff and keep them away from the poorly written stuff. Yeah, planetarium. There you go. People got great recommendations. Planetarium, go out and see a meteor shower when you can. Teach them about the phases of the moon. There's lots of good stuff that you can do that will encourage them to be interested in science and science fiction and all that. Allie. Sorry for the... Oh, Allie. Is it true that 3i Atlas stopped for 11 minutes when it went by Mars, and how is that even possible? I said I was going to do this, and I'm trying to be strong. But no, it didn't stop when it went by Mars. It is still going more than, 58? It's still going very, very fast. It is still the fastest interstellar object that we have ever seen pass through the solar system. It is following a perfect gravitational... It's following a perfect trajectory as predicted by Newtonian mechanics. It is doing exactly what a rock or a ball of snow and rock and other volatiles would do if you dropped it towards the sun, or I guess threw it into the solar system and it flew past the sun. And the problem is that there are people who are just literally making things up now on the internet. And so the thing we have to do when we hear that is we have to say, what's your source? How did you hear that? And then we have to look at the source. And if they don't provide a source, then you can't take them seriously. If you go back and look at my 3i Atlas video, I literally provide links to every single science paper that I'm referencing. And we highlight in the science paper where the person is saying that. That's the level of sort of facts checking that you have to do to be able to say this stuff and not just be making stuff. Like, I can make stuff up all day about 3i Atlas, boy, but I won't. But I could, but I won't. And so, so that's what we're dealing with right now. So I'm sorry that you are getting a lot of stuff that is being said and is like purposefully trying to scare you for no reason apart from people wanting to get clicks. And that makes me really angry. So angry that I might rant, but I won't, because I promised I wouldn't. Steve Ross, what if simulating the universe is technologically easier than physically going to and exploring the whole universe? Could that solve the Fermi paradox? Maybe they just watch us on alien computers. It's funny, we got almost this exact question on Astronomy Cast earlier today and answered it there. And so this is great because it's all kind of fresh in my brain. Our computers are getting better and better every year. And they're getting more and more accurate and more powerful in what they can simulate in the universe. But the level of detail that they can simulate in these simulations is, a galaxy or particles in a galaxy. And they can also simulate some of the dark matter and the effects of dark energy, and even starting to simulate things like neutrinos moving through the galaxy, but it's still a very rough simulation. They're at the point now where they can start just after the Big Bang, they can run the simulation forward, and they can see the results that look roughly the way the universe looks today. And that's a very good sign that your simulation ends up simulating a thing that is kind of like how the universe looks. And there's a whole bunch of new observatories that are coming online or have already come online in the last couple of years. This is a big priority for the astronomical community, which is to understand the shape and the composition of the universe at different epochs. So there's 4 missions, or I guess there's 4 instruments missions that have come out or about to come out. So the first one is the DESI survey, the Dark Energy Spectroscopic Instrument, which is a ground-based telescope. There's the Euclid mission, which has been launched by the European Space Agency. There's the upcoming Vera Rubin telescope, and then there's the Nancy Grace Roman telescope. So 2 space telescopes, 2 ground observatories, and they're trying to map out the composition of the universe at different times. So how much was dark matter? How much was dark energy? Where was the dark matter? Where was the dark energy? What about stars? How are they moving? And just get a sense of that all the way back to the beginning of time. And then you have much better information that you can then put into your simulation to try to predict what the future of the universe would evolve into and make a better job of doing those simulations. But simulating like a galaxy or even simulating star systems and planets forming in star systems. If you can get to the place where you start your simulation and you start by simulating from the Big Bang, it goes all the way through galaxies and it simulates all the way to stars and it shows the right compositions of stars and it simulates planets orbiting around those stars, you don't get life, right? You don't get simulations of life from that. Simulating life is going to be some totally different process. And maybe one day you can kind of mash those things together where you're simulating the large scale structure of the universe and you're also simulating the chemical composition on some planet that's giving you the first life forms, then you're somehow integrating them together. So I think it'll be a long, long time. But your suggestion about the Fermi paradox that advanced civilizations maybe turn inward, I think that's a very legitimate possibility that, once a civilization gets so advanced, then there's sort of like more to explore in their virtual worlds than there is in the real universe, which is a very weird thing to say because the real universe is the thing that's real. But what if you could make an unlimited amounts of reality? I mean, it's not even reality. What if you could make an unlimited amount of things to consider, things to explore in this virtual world, and that becomes more interesting to this civilization? And so all you have to do is run very powerful computers, and then you don't even have to risk the danger of space travel, but you can run these ancestor simulations. And that's where the simulation hypothesis kind of comes together, where you say, okay, if we're going to be simulating the universe or some reality, and our simulations are going to get better over time, eventually our simulations will get so good that we're running a ton of simulations, millions of simulations, billions of simulations. And in those simulations, other people will be running more simulations. And then you say, so are we in a simulation? And like mathematically speaking, maybe, but there's no way to tell. So yeah, I think there's a possibility that any advanced civilization is going to find, and this could be inevitable, right? Like this could be the great filter, that these advanced civilizations find it inevitable that the most interesting thing is to not bother exploring the cosmos. It's to search, to explore these virtual worlds that they're creating. But then you put yourself at risk to the civilizations that don't do that, and they just land grab, right? When the board comes by, they don't care if you're just playing your video game. So it makes sense to also explore the real universe. And so now I'm back to square one. That's working great, Chad, if you're still watching. Paige Potter, what's your most unpopular space take? Obviously, it's the one where I think we're alone in the universe. People just think that's bonkers. Although I think people are starting to come around. I feel a little guilty. Do you? I mean, you guys, most of you know my position on this, and I wonder, have I convinced you, or do you still think I'm super wrong? Let's have a poll, because now I'm worried. Poll? Okay. Have I changed your mind about aliens? Okay. So I don't want to change your mind. Feels like a terrible idea. GFA Basic 32 for Windows. Can we just call you GFA Basic? Do you follow Alien Earth TV series? Absolutely. Alien Earth, this is the new series about the Alien franchise. It was played on Hulu, I think. We saw it on Disney Plus here in Canada. And it sort of tells the story of corporations that are fighting over various extraterrestrial species that they've brought back from they're not really clear where they got them. And so there's it sort of expands the xenomorphiverse, where you've got not just the traditional chest bursting, egg laying xenomorphs, but you've also got a bunch of other super weird aliens that they bring back, and they're very dangerous and they are scary, and they've got a bunch of little kids who've had their consciousnesses transferred into robots, and it's a very weird story. But it's very good and very well told, and really feels like it does homage to the original Alien franchise, and I loved every second of it. And in fact, put it in my top. I think I'm putting it in my top 10. I actually gave you my top 10 sci-fi stories a little while ago, but now I think Alien Earth is going into the top 10. It was that good to me. Okay, no, good. That's great. I've changed 18% of your mind, and 82% I have not. So I think that's absolutely perfect. I can't wait to be wrong. Yeah, specifically, when I said change your mind, I'm asking, before you started watching my channel and heard my position on extraterrestrials, you were like, yeah, life has to be everywhere. The answer to the Fermi paradox is we just haven't looked. And now you're like, this is very compelling that we don't see any aliens. And so it could mean that we're alone. Han Solo, did you like Blade Runner 2049? I loved it. Yeah. I've been spending a lot of time working on my top 100 list now. So probably within the next couple of weeks, I'm going to post my top 100 movies and TV shows, sci-fi related movies and TV shows. Because I think for a lot of people, you hear their recommendations and there's stuff you've already heard of, right? Yeah, I've watched Andor. Yes, I've seen whatever, right? SG1. And so I've got a lot of kind of deep opinions, stuff that's maybe a little out there. My wife and we watch a lot of sci-fi. And so best wife ever. And so we've had a chance to watch everything you can think of, we watched. And so I can put together what I think is my best opinion. I'll do that. Apropos of wet snow, have you read the Kim Stanley Robinson Mars trilogy? Yes, I have. I might recommend that to the boy, actually. Yeah. Red Mars, Green Mars, Red Mars, Blue Mars, Green Mars. And they're terrific. I really enjoyed them. I read the Mars trilogy about when I was just getting prepared to start Universe Today. So about 25 years ago. And I read The Case for Mars by Robert Zubrin, and that got me really excited about just Mars exploration in general. And then I read Red Mars, Blue Mars, Green Mars, and that's the fiction companion to The Case for Mars. And I was all in, locked in. I'm so enthusiastic and excited about this now that I'm going to start a space website. Little did I realize this would turn into my career to be a space journalist. So yeah, did I read Red, Blue, and Green Mars? Yes. And in fact, it's the cause of a big chunk of my like identity at this point. Ed, is there a question about the universe that's literally impossible to answer? Almost certainly, there are questions that we will never know the answer to. And when you think about like some of the biggest questions, like where did everything come from? Right? Why is there something and not nothing? That's a question about the universe, right? Why does the universe exist? And if you go back through, all of the evidence that we have about what's in the universe, we get to this place just nanoseconds after the beginning of the universe where we can no longer really answer any questions about the nature of reality at that point. And there is this hard stop at the very beginning of the universe, at the moment of the Big Bang. It was like a clean slate. It wiped the evidence of the universe. Whatever came before was wiped, and you had the universe that we live in today. Maybe, right? Probably. But maybe there's some echo, there's some piece of information that's here in the universe that is some hint at what came before. And so that would be incredible. I guess Nobel Prizes all around. And yet, all that does is just push the question one step back. Because, okay, so now we've detected these echoes of the previous universe, and we've been able to figure out that some of the the constants of the universe were the universal constants were slightly different than what they are now and had a different universe. And there was something that led to the Big Bang, and we kind of understand it. And you're like, okay, fine. But what came before that? Is there an echo inside of an echo? Well, it was just a big cycle. It always had been going. Okay, well, what started the cycle? Where did the first universe come from? Right? Like, you will always get to this place where you're like, yeah, but where did that come from? That you will never be able to answer, because it's turtles all the way down. And so that's the kind of question that you have to be comfortable knowing that the answer will always be, we don't know, that we will never know. Like, what if we wake up and realize that we're actually in a simulation? Okay, fine. So where did the simulators come from? Right? Oh, they're in a simulation too. Okay, fine. Where did they come from? And so no matter how you try to crack into this problem, you're always going to get to, I don't know. We don't know. We can never know. And to know that there is this horizon of unknown out there that can never be crossed. In the beginning, sort of feels unsettling. And after a while, you feel very comfortable. And after a while, you kind of seek it. I really love the feeling of the mystery, of not knowing the answers to things. And I think that's like a place you get to where some mysteries you hope are going to unfold and you'll find out the answer. Other ones, you have to just be comfortable in that uncertainty. And I think it's fine. I kind of knew the answer, says Ed. Yeah. Yeah. Where are we at? Okay. I saw images. Why can't we feel the expansion if it's happening to space-time? My cells are getting farther apart. Could it be that the strong nuclear force is getting weaker? So the expansion of the universe is happening at the largest scales, and it is a very, very weak process. So weak that almost every other force is millions, billions of times stronger than this force of the expansion. And so, for example, I mentioned this. Well, for example, I'll give you some examples of things that are stronger than other things. So, for example, you've got, like, you take a magnet and you put it on your refrigerator. Now, the magnetism that's holding the magnet to your fridge is stronger than the gravitational mass of the entire Earth that is underneath it, trying to pull that magnet off of the fridge. And yet the magnet is very strong. That the atomic force that is holding your body, your atoms together, is stronger than the gravity that's trying to pull you into a blob. That's how stronger the forces are that hold on to our body. And so, yeah, there is dark energy. And if dark energy works the way people think it does, then it is this expansive force that is happening everywhere in the universe, even a little bit inside your body. But the strength of that expansion is minuscule compared to the force that is holding all of the parts of your body. The chemical bonds that are holding your molecules together, the atomic bonds that are holding your atoms together, the gravity that is holding the planet together, that's keeping you down on the planet. All of that is just ludicrously stronger. It's only when you get to about 5 million light years away, double the distance than Andromeda, where the force of gravity between two galaxies that are trying to pull each other together is overcome by the dark energy expansion that is trying to push them apart. And that's the point where two galaxies won't be able to pull together because this dark energy is pushing them apart. But closer than that, gravity is dominant. Closer than that, the chemical bonds holding your molecules together is dominant. The atomic force is what's dominant. Okay. Michael Shea, when talking to physicists, do you get the sense that there's a growing consensus that LCDM is wrong or at least flawed? So the LCDM is the lambda cold dark matter model. LCDM is the lambda cold dark matter model. Say that 5 times fast. And that is the scientific consensus right now for the domination of dark matter in the universe. And not just that dark matter is the dominant source of mass in the universe, but it is a kind of particle that is cold as opposed to hot. So neutrinos are hot particles that don't interact with anything, and they move very quickly at close to the speed of light. And whatever dark matter is, it is probably cold in that it doesn't move very quickly and kind of hangs around in big blobs that can then interact with regular matter with its gravity. And so no, absolutely not. When you talk to the scientific community, you talk to astronomers, the lambda CDM model is the one that is considered to be the scientific consensus right now. It makes predictions that accurately match the observations that astronomers are making of the universe. It better than anything that's ever been thought of so far, and that's why that model. You look at the kinds of predictions that it makes, or you look at the explanations that dark matter makes, and you can make further predictions. You see how the rotation curves of galaxies match whether there's a big halo of dark matter around a galaxy. And then you can see the gravitational microlensing from dark matter as its sort of large chunks of it are causing light to bend in subtle ways. And there's a lot of experiments that are being done right now that are going to map that out with better accuracy in the coming years. And, I think that when James Webb first launched, there was this initial rush, and it was finding a lot of stuff that was very interesting, and there wasn't a lot of time to really do a deep analysis. Specifically, there wasn't time to do the spectroscopic analysis on the most distant galaxies. And so you got a lot of papers, kind of a rush for papers for people to say, oh, we found this really big galaxy early on in the universe. We found this surprisingly large supermassive black hole early in the universe. And then you got sort of a regular cast of characters that show up every time there's any kind of controversy, who pull out their paper that they've been waving around for 30 years and they go, pick me, right? I can explain why the universe isn't working the way the theories had expected. And their ideas have been disproven already. They've failed to make predictions that match the observations. They have been discarded a long time ago, but for ego reasons or whatever, they can't let it drop. And so they switched to marketing. And so after James Webb came online, we saw a lot of marketing. And that's the word I want to use, is marketing, from people who have alternative theories about the universe, but don't have the evidence to back it up, don't have the peer-reviewed literature to back up what they're saying, who have alternatives to Lambda CDM. Lambda CDM is still very strong. Now, there are alternatives, and people seriously consider them, but none of them are sort of more widely adopted by the scientific community than this model. So, and then over time, as more work was done with James Webb, as more spectroscopy was done, as various interesting discoveries were then, they had follow-on discoveries, or after there were interesting discoveries, astronomers made follow-on observations with other instruments, with ALMA, with Chandra, with Hubble, and then you got things starting to make a lot more sense. That, you know, there's this idea of survivorship bias, that you know, when you're seeing very bright galaxies early on in the universe, is that because all galaxies early on in the universe were bright? Or is it just that you're only able to see the brightest things? And so that's what you see. You don't see all the fainter galaxies. And now over time, we're getting a much better sort of census of what's there in the early universe. You know, and so right now, there are so many lines of evidence that are well supported by this current Lambda CDM model that it's going to take a lot to come up with another model that explains it better. You know, there's the idea of, you know, oh my God, what's the name for it? Non-Newtonian gravity. Anyway, there are a bunch of alternative theories to explain dark matter. And some can explain very specific aspects of dark matter, but they can't explain them all in the way that Lambda CDM does. And so until something comes along that does a better job of explaining all of the current observations, that fills in current mysteries, and then makes predictions for other phenomena that people need to go and look for and confirm, that's the gold standard. Lambda CDM is going to be the one that most people are sort of agreed upon. MOND, yeah. Modified Newtonian dynamics. Tom Colby, I think the universe is organic and we are just a speck inside a larger organism. You know, there's a lot of, you know, this kind of, you know, there's a lot of, I'm trying to think of a way to describe this. So one of the things that science does really well is helps us distinguish between vibes and what appears to be evidence that matches our observations. And for the longest time, really for most of human history, we've relied on vibes, right? That why is there lightning? Because the gods are angry. Why do we have good weather versus bad weather? Where do people go when they die? You know, all this kind of stuff. We have all these just sort of vibes, and different cultures come up with their explanations, and these turn into pantheons of their gods. These turn into various myths and sort of cultural things. And it really wasn't until the scientific revolution, like 500 years ago, where we got to this place where we had to come up with a more rigorous way of being able to sort of analyze the natural world around us and come up with methodologies where you sort of go into it without any expectations. You just try to understand nature as it is. And that through that process, you can sort of come up with things that are repeatable, that anybody can perform the same experiment and get the same outcome. And then that gives you progress. And that's when our human society moved into this sort of modern sort of place that we are today with all of our technology and all of our scientific understanding of everything around us. And, and yet it all often comes back to those sorts of hunches, right? The feeling that you're having, where you're like, okay, like I think the universe seems organic. When I look out at the universe, the way things are balanced, the way when you look at the shape of the large scale structure of the universe, it looks very similar to neurons in the brain. It looks very similar to the kinds of shapes that algae colonies will grow. Like there's something very organic to that. And so that's the hunch. That's the sort of the eureka moment, right? Where you're going like, maybe this is like the nature of the universe. This is some aspect to the way things work. And up until 500 years ago, that's where people stopped. Someone would go like, I think the universe is kind of organic, right? And someone would go like, yeah, you're right. And then 100 years later, it's, there's a book that people have to, there's 100 years later, there's like some kind of sort of cultural awareness. It's just been locked in. And what science does is says, okay, great. But now you have to prove it. Now you have to find evidence that matches what you're saying. If the universe is organic, what does that mean? What things can you observe that would tell you that it is organic versus the things that would tell you that it's not organic? And then if you find those things, can you use it? Does it have any explanatory power? Can you explain some of the aspects of the universe, some of the mysteries of the universe using this theory in a cohesive way? Can you make new predictions about the universe? Can you explain it in math so that people can actually sort of make these predictions very rigorous? And so I think, whenever you have these sorts of thoughts, you want to try to approach it in a scientific way to say, okay, how does this explain the universe? What would I see if this was true? What would I see if this was not true? How would I disprove my theory? And keep going with it. And this is what leads to a fascination with science. And this can lead to a whole career for you. So, go with it, man. But do it right. Silas Miller, will Vera Rubin find a bunch of new Earth colliding asteroids? Yes. That's awesome. Let's see here. Yeah, okay. Yes, Vera Rubin will be the perfect instrument to find asteroids moments before they hit us. And this is a thing that's fairly new. In about the last 10 years or so, observatories have been, in the last about 10 years or so, astronomers have developed these all sky surveys, things that are scanning the sky every night. That's how you get Atlas, right? Atlas is one of these sky scanning telescopes. It's kind of like a precursor to Vera Rubin, and it finds a lot of objects. Like 3i Atlas is the one we're all comfortable with. 3i Atlas is the object that we're all familiar with. But there are a lot of other objects that have Atlas in their name because they were found by this telescope. Every night, it's scanning the sky. It's identifying new objects and turning them up. And so now there is this asteroid early warning system that's come online in the last couple of years, where one of these telescopes finds an object, submits the trajectory to the Minor Planet Center. The Minor Planet Center calculates the trajectory, and if it turns out that it's going to hit the Earth or come extremely close to the Earth, this alerts a whole bunch of other telescopes. People get notifications, they take more images of it, and they're able to now predict the impact of one of these asteroids to like the place on Earth where it's going to hit, the time that it's going to hit. And people have been able to go outside. People have gotten an announcement that one of these asteroids is going to hit their area. They can go outside, they can look up, and then right on time, they can see the fireball going through the sky as the asteroid is on its way. And so Vera Rubin is the kind of instrument that is designed to scan the night sky night after night after night at a level of depth that gives it more of a warning. And so instead of it being something that's found the night before it hits, it's going to be finding things that are a few days, a few weeks before it hits. Small objects. Like, it's key to it's really important to say these are all small objects, right? These are objects that are 1 meter across, maybe 5 meters across. They don't do any damage. They just explode in the sky, or they leave a really cool trail as they pass through the atmosphere. And hopefully we'll get to this place where every fireball that you could see has been predicted. And so, you'll check your calendar and you're like, oh, we've got 2 fireballs that are coming tonight. One is going to be at 3:15 a.m. One is going to be at 3:15 a.m. It's going to go from the east to the west, and it's going to start off in the constellation of Orion. And you go outside and you look in the right direction, you check your watch, and then there it is, big bright fireball. And so I've talked in previous episodes how fireballs are these objects that are very, very rare. I've seen one in my life. Most of you have seen 1, maybe 2 fireballs in your life. Imagine if we could see these all the time, because they're happening all the time. It's just that we don't get any kind of prediction on when they're going to happen. And now we're turning the universe into this kind of clockwork machine where telescopes like Vera Rubin are giving us all the warning that we could want. So it's a pretty exciting time for a lot of fields. It still hasn't sunk in with me on how dramatic a change Vera Rubin is going to be for our understanding of the cosmos. And we are just a month away from it kicking up into high gear. Pete Rund, what do you say to the applied use of Occam's razor for the theory that we are some of the first, a lonely, boring, and depressing idea? No, that's my position, that we're alone, or we're the first. So I find it not boring. I would prefer a universe with lots of alien civilizations. That would be interesting. A little lonely, because it sort of would be cool if there was other civilizations out there. But not depressing necessarily. It just means that we have a job to do. We have to explore. We have to help life get out into the universe. That's our task. Santiago T, is it possible that 3I Atlas came from the Oort cloud and not another star system? How are we so sure it is an interstellar object? So objects that come from the Oort cloud follow a parabolic, no, it's an elliptical object. Okay, so objects falling from the Oort cloud follow a elliptical orbit. So they are following this giant ellipse where they go around the sun and they go back out into the Oort cloud. And then theoretically, they do the same thing. And all you have to do is calculate the shape of the trajectory around by the comet, and you can tell whether or not it's going to be captured by the solar system or not. While the interstellar objects are following a hyperbolic orbit. So they are going to take them in. They brought them in from outside the solar system, and they're going to continue on an escape trajectory out of the solar system. Right now, 3I Atlas is going 58 kilometers per second. And so that is much beyond, well beyond the escape velocity of the sun. And so we know that it's going to pass through and then just keep going. And it's going very fast. It's going faster than Borisov or Oumuamua. And you just calculate the orbit and you know. And so if it is on an escape trajectory back out of the solar system, it'd be very weird that it, think of a swing, right? Here's a good analogy to use. Imagine you take a swing and you take it back to your face and then you let go. And the swing goes all the way out, and then it comes all the way back, and then it just stops right at your face and doesn't touch you, and then goes all the way back and then all the way back, right? It can't go faster than just coming back to where its starting point was. And so any comet that is dropping down from the Oort cloud can't go any farther than where it started. But the interstellar objects, they can go much, much faster because they started with a velocity that is moving them outside of the solar system. Diego's question. Okay, Jay Cowan. Using our sun's mass as a gravitational lens to create a telescope sounds great, but how do you steer it and point it in different directions? Sounds pretty limited. Yes, using the sun as a gravitational lens is extremely limited. So in order to use the sun's gravity, you have to take your spacecraft out to a distance of 550 plus astronomical units away from the sun. Then once you're out there, then you look at the sun, you block the light from the sun, you see the distorted gravitational image around the sun of whatever it is that you're looking at, and it magnifies the light to your telescope by orders of magnitude. It's like 30,000 times or something like that. Like, it's huge. It will allow you to see a megapixel image of an exoplanet that is, say, 100 light years away on the other side of the sun. So that's the upside. The upside is that you're seeing 1,000 pixels by 1,000 pixels of a planet. You're literally seeing the continents, mountains, the oceans, the weather systems on that planet. The downside is that you can only look at that one object. And so to say you're limited, yeah, you cannot steer this telescope. You can only look at the one object. That when you launch your spacecraft, it has to go down this very specific cone, this corridor on the other side of the sun from whatever it is the target that you're trying to image. It has to remain within that very tight area the entire time. Just keeps getting farther and farther away from the sun, watching the sun, and sort of keeping itself in line with the sun and then whatever it is, the target that you're attempting to image. And so if you want to, if another even better planetary system has been discovered and you want to be able to get eyes on that planet, you have to launch another spacecraft out to the solar gravitational lens to image it. And so whichever world is chosen to be the target for the solar gravitational lens telescope, it's got to be pretty special because it's going to be very expensive to send a spacecraft 500 plus astronomical units away within a normal human lifetime. Like, that's farther than the Voyagers. Let me see. Voyager 1 is 168 AU. So it's a third of the way to the solar gravitational lens, and it's been traveling for 50 years. So would you be willing to wait 150 years for the solar gravitational lens? Jeff Smith, any comment about the jet plane being struck by space debris? I don't have any comment. I saw that in the news today, and I didn't see a source that I trusted for it, and so I didn't bother reporting on it. So I don't have any additional information. I was aware of it and said, I'll wait for that story to marinate a little before we start reporting on it. Dr. Uncle Phil, is the Lunar Gateway still a mission? That is a great question, and we don't know right now. So I need to sort of walk through alternative timelines I need to walk the multiverse here to be able to figure out what's the state of the Lunar Gateway. So the Lunar Gateway is going to be the next big project that NASA was going to be undertaking as part of the Artemis mission. So Artemis 1, 2, and 3 are going to return humans to the moon by Artemis 3. But then Artemis 4 was going to begin the construction of the Lunar Gateway. And there's about 5 chunks of the Lunar Gateway that are going to be coming together, different modules. And those modules are already in varying levels of completion. Some are already pretty much ready to go and in the testing stages. Others are quite a ways away. And the goal with the Lunar Gateway is that you put this space station into a halo orbit around the moon, a high altitude lunar orbit. And so it's going to maintain this orbit around the moon that puts it sort of in view of the Earth at all times, and yet occasionally brings it close to the moon so that they can then make landing attempts on the moon. And so the way this will work is that you will launch astronauts from Earth. They'll fly to the Lunar Gateway. They'll dock with the Lunar Gateway. They'll switch to their landing system. And either that'll be like a 1-part lunar lander, or maybe there'll be some kind of ferry system. So it takes them close to the moon and then it detaches and comes back to the Lunar Gateway, and then they go down to the lunar surface, and then they come back from the lunar surface and they meet with the ferry and it brings them back. And so every chunk of this process is going to be reusable. You'll have a reusable rocket. You'll probably have a reusable rocket that's taking you to the Lunar Gateway. You'll have a reusable ferry that's taking you to and from the moon, landing system. All of this will be reusable, and eventually you'll just be refueling all of the parts of your mission. So that's the goal, and that's why they're trying to do it, because back in the Apollo era, you just had footprints on the moon. You had people go land on the moon and then they didn't go back for 50 years. And so it'd be great if there was now this ongoing sustainable exploration, lunar base, mining for water, learning to live in the lunar environment. Eventually we get some larger station on the moon. And so until this year, this was the plan. You'd have, the 4th Artemis would launch the beginning part of the Lunar Gateway, and then they could start using it for future human landings on the moon, and they would just keep building it out until it was a safe harbor on the way to the moon. So the White House put in their budgetary request a few months ago, and they slashed a lot of the budget of NASA. They cut it by about 25%. And so that cut, they wanted to cut about 40 missions from NASA, either missions that were already operational, like Juno, New Horizons, as well as missions that are in development, as well, Nancy Grace Roman, as well as missions that are sort of in the planning stages right now, like the Mars sample return mission and things like that. So they put in that budget request, and that included canceling the Lunar Gateway, as well as sort of scaling back parts of Artemis while growing other parts of Artemis and trying to accelerate the exploration towards Mars. And then Congress pushed back against the budget that had been put together by the White House and wanted to have pretty much the exact same funding, and for most of the missions that were going on with NASA to be sort of continued. And that was a relief, because it meant that we were going to get the Lunar Gateway. We were going to not get the cancellations of all of these missions. And then the government shutdown happened. And so where we are now today, the time that I'm recording this, we are 20 days into the government shutdown. And a lot of the cuts and changes that the White House wanted to make are just kind of happening by default. So like 10% of the workforce at NASA JPL has been let go. You're seeing a lot of missions that are being shut down right now. And depending on how long the shutdown lasts, we don't know sort of what the results are going to be. In the best case scenario, the shutdown ends, there's a compromise, people come back, it follows the Congress funding, there's smaller teams because people have left, but they're able to put it all together and hire new people and continue on. Worst case scenario, the shutdown lasts for months, people have to go get new jobs, the brain drain is sort of decays huge chunks of sort of NASA expertise, and NASA is a shattered version of what it was before. So right now, the time that I'm recording this, there's so much uncertainty, which has just been the case for the entire year. There's just been so much uncertainty, and that's just going to continue. We're going to just get uncertainty on top of uncertainty on top of uncertainty. And I'm sure for certain kinds of fields, that's super fun. Everyone loves uncertainty. But for long-term sustained exploration, science projects, things that require slow and steady achievement towards the goals, that's anathema. That is very, very bad. And so I think right now, unfortunately, sort of U.S. space exploration, space science is in shambles. And we're going to have to sort of wait and see what's going to happen and whether all these pieces can be put back together again. Cage, what are some notable Canadian Space Agency missions and projects, past, present, and upcoming? So the most famous Canadian Space Agency mission is the series of robotic space arms. So in the space shuttles, there was the Canadarms. There's the mobile servicing system that's attached to the International Space Station. And there was planned to be the Canadarm version for the Lunar Gateway. So like that's what we do. We put arms on things. Now Canada is also working on a rover, and they just named it, and I forget the new name of the rover. But Canada's working on a rover for the moon. And then a Canadian astronaut is actually part of the Artemis 2 mission, is going to be going around the moon. So, Canada's had a lot of great astronauts who have gone to the International Space Station, flown with the space shuttle. So, we don't have a big budget in Canada for space exploration. We have a fraction of the population of the United States, a fraction of the, a fraction of the budget and GDP of the United States. But I think we punch above our weight in terms of science. And I think, we've had a really good partner with the United States, right? Instead of trying to make your own completely separate space agency, you work in partnership with the United States. Canada provided one of the instruments on the James Webb Space Telescope. So that's the kind of work that Canada tends to do is partners up with other organizations, ESA, NASA, JAXA, and supplies instruments, people, expertise, hardware, funding for those missions. Sorry, just looking at the questions. Man, so many. The wise YouTube commentator. Any thoughts on the egg theory? I've never heard of that. I don't know what that is. Miras, why only so few of us on the live? There are 481 people. That seems like a lot of people. For me, anyway. Sean 12, do you get frustrated with the growing popularity of the wacky conspiracy contrails controlling weather, flat earth, the jab, etc.? Yeah, I mean, like, this tends to trigger a rant in me. And so I just get sad. that science is is a methodology that works really well, that has given us a ton of benefits in our society. And there's this kind of war on expertise right now. And it's not just science, it's just kind of everything. It's policy, all kinds of things. People are railing against expertise. And, you know, at the heart of it, I think there's some legitimate concerns. There's an accumulation of power. There's an accumulation of wealth. People are feeling marginalized by society, and they're looking for a cause. They're looking for a reason why. And people are able to redirect. People are able to prop up the causes. And science happens to be one of the things that has been propped up as one of the causes for the problems that people are experiencing. And so it's caused a real sort of aggression towards science, something that's very unique, I think, to Western culture, very different in Eastern culture, where it's sort of being a scientist, being an engineer is sort of seen as the ticket out of poverty, seen as the ticket of becoming a very advanced society. And, you know, maybe that's just the thing, you just don't realize how good you've got it until it's gone. And that's, you know, I think we're in unfortunately, the find out stage. When you have measles cases rising, you have coastal erosion, like you have all these problems that have been predicted by science. And not only are people not taking the prediction seriously, they're hostile to the scientists and railing on them as attention starved, money grubbing, whatever, right? Like, it's ridiculous. Like, when you look at all of the possible players, all the people who have all the stakeholders in climate change, right? Scientists don't make very much money. Who does make a lot of money and has, you know, their climate, you know, if there was serious action on climate change would hurt their bottom line? I wonder. But they've been, you know, they have money to redirect people's attention to distract them. And so it's just causing a real sort of takedown on science. And it just makes me sad. Now, for a lot of the specific stuff, I just don't deal with it. I just don't, like, it's not like I, you know, cognitively disconnect from it. It's just that I don't think it's interesting to entertain clearly non-scientific theories. And I've sort of, you know, I've kind of gone overboard in dealing with the 3i Atlas stuff just because it's so outrageous. But I find just, like, in general, if you're going to pander to, it's like you're rewarding the wrong audience, right? My audience, the people who I want to interact with, are the people who love science, who are fascinated by space and astronomy, who watched space shuttle launches, who were there for the moon landings, who are excited to see new pictures coming from the Vera Rubin telescope, who can't wait to hear more about what's happening in space exploration and astronomy. And they're, you know, they're my favorite child. That's a bad analogy. They're my favorite, right? Those are the people who I want to lavish my attention on, is the people who want this stuff, who are interested, who have a genuine appreciation for science. I don't have time for the people who, to whatever degree, are railing against science or are making stuff up wholesale. Right? We can choose the conversations that we have in this world. We don't have to spend time talking to people who are spouting nonsense. That's a them problem, not a you problem. And by you engaging with them and talking with them and chatting with them about it and trying to convince them, and then it becomes your problem, and you don't need to. So, you know, in general, when I'm strong, I tend to just focus on talking about the science, talking about the interesting stuff that's actually happening to an audience who understands and believes in it. And that's enough. You know, I think there are a lot of channels that do well by directly confronting the nonsense. And, you know, I think about, like, say, Professor Dave Explains or Simon Dan. And that's just not me. Like, it's just not me. Like, I just don't feel like putting on my armor and wading into combat with people who are spouting nonsense. And I think it's important work because someone needs to push back against it. But it's not me. It's not for me. So I just, I'm definitely frustrated, but I don't really find it's very useful for my time to try and push back against it just directly. I just would rather spend my time entertaining you. And then if you don't believe this stuff, if you don't like this stuff, it's not for you, right? Like, just go find something else. Go find a channel that talks about the stuff you want to talk about, that wants, like, it's fine, right? It's fine. This isn't for you. No, I'm going to be strong. Justin D. Let's talk about the three objects traveling information with 3i Atlas. There are no objects traveling information with 3i Atlas. Somebody has made that up. They've just invented a whole cloth, wrote it on the internet, and are hoping people believe it for the clicks. But I'm going to be strong. Paige Potter, if the Great Filter is ahead of us, what part of human nature do you think will be tested most? The Great Filter is not a test of human nature. The Great Filter is an inevitable, if it exists, the Great Filter is an inevitable outcome of an intelligent species, if it's ahead of us. So, like, the gist of the Great Filter, this is the theory by Robin Hanson, that there is, the way you explain the Fermi paradox, the lack of us seeing aliens, is that there's something bad happens to every civilization. Now, maybe the Great Filter is behind us, that the Great Filter stops new species from becoming multicellular, and so we've somehow passed through the Great Filter, and now the universe is ours to explore. But maybe the Great Filter is in front of us, that we have yet to run across the Great Filter. But when you think about the numbers involved, when you think about the 100 billion stars that are in the Milky Way, the 100, with multiple planets, that is hundreds of billions of separate planets where life could have started. And if life started on many of those worlds would have gotten advanced and become technological civilization. And yet none of them went on to fill the solar system with von Neumann probes. We don't see monoliths poking out of the moon from all of the civilizations that have visited us and left their calling cards. The universe seems empty. And so whatever this, if the Great Filter is in front of us, then it is something that has snuffed out every single technological civilization before it was able to expand out of its home system. All of them. In a way that was 100%. Right? And so we can't predict it, because if it's a thing that we could predict, it's the thing the other civilizations could have predicted, they could have avoided it. And so we can't, there's no aspect of human failing that it would play upon, because it would literally play upon the exact same failing of all aliens, all technological civilizations. It's the thing that unites all technological civilizations, is they are doomed by the Great Filter. So, and there are things that we can imagine, like, the robot uprising, getting hit by an asteroid strike, having a nuclear war. Those are all things we can imagine. Therefore, they're ruled out because we can avoid them. We can use our wisdom to sort of get around these things. But then there's maybe there's some kind of a science experiment. Maybe there's you get to a certain level of technology and you accidentally light your atmosphere on fire. It happens every time. That's the kind of thing. So, is it progress? The human failing is that we want to keep coming up with new technology, I guess. Ambition, maybe? But it seems pretty broad because it's happened to every alien civilization out there too. Happy birthday, Lucas. Yeah, there's no Great Filter for alone. Or if the Great Filter is behind us, then we're the first civilization to get to space. And then Great Filters, we did it. We made it. Um, Oh, we've gone to the next page, haven't we? Yikes. Okay. Syndrome. What's the deep intel on why Jared Isaacman's nomination was withdrawn? I don't really know. There was an interview that Isaacman did with Tim Dodd, was it? I think, talking about it, and you can sort of read between the lines about what happened. But it sounds like he just wasn't towing the administration's line on a bunch of things, and so he just didn't have enough loyalty for what they were looking for. They looked for someone new, which was too bad, because he sounded like a really interesting candidate. I was kind of excited to see what Jared Isaacman would do as the leader of NASA. I think there are other people who would be more interesting, but of the various cabinets that were being filled, I was kind of intrigued to see what was going to happen. But apparently he's in talks to become NASA administrator again now, so we'll find out. Because right now, was it Sean Duffy is doing it, and he's the transportation minister, and also has like 9 different portfolios that he's trying to manage at the same time, including NASA. But maybe it won't matter, because NASA will be in shambles once the shutdown is over and the budget cuts are done. So who knows what's going to happen? Yeah, but I have no intel, no deep intel. I'll reach out for an interview. I'll try and talk to him. IARCSIM. How much is China's space program creating a feeling of competition with NASA? NASA seems far ahead of China, but is the feeling that China could catch up with NASA helping it get more funding? So right now, NASA is very much ahead of China in terms of technology, in terms of knowledge, in terms of missions, right? There are multiple space telescopes operated by NASA. They're building a giant moon rocket. There's like a lot of technology that NASA has worked on, and a lot of expertise, institutional knowledge and expertise. And then they have a partner with SpaceX that has a lot of experience as well in launching rockets, and now is building a completely reusable rocket platform. So there's a lot of momentum going on at NASA, but China's catching up quickly. And so their budget is about half of NASA's budget, maybe a third of NASA's budget. But they have like 35-year plans for everything, and they're sort of following their plan beat by beat. They've sent a mission to Mars, and they put a rover on the surface of Mars. They've retrieved multiple samples from the moon and brought them back. They've also retrieved a sample from the far side of the moon for the first time. They're on their way to retrieve a sample from an asteroid, and they're preparing to send humans to the moon by 2030. Now, they may make it, may not make it. And I think up until this point, with the development of the Artemis mission, everyone just kind of assumed NASA was still going to get back to the moon before the Chinese make it to the moon. But there was a meeting a couple of months ago where people are seriously saying, okay, actually, if there's any more problems, any more delays with Starship, any more delays with the Artemis 3 mission, NASA might not actually get to the moon faster than the Chinese. And so then, right, the Chinese will be operating the only space station at this point. After 2030, when the International Space Station comes down, they'll have the Chinese space station. They'll be the sort of not only the first people to return to the moon in 50 years, but they will be returning to the moon on a regular basis. They've got a whole plan to eventually leading to a permanently inhabited base on the moon. They're building international partnerships with a lot of other nations who aren't flying with NASA. The groups in the Middle East, India, Pakistan, like a bunch of other countries, they're building these partnerships with them. Like India's got a really good space exploration sort of system, and they're getting better and better and better. And they're probably going to send humans to the moon in the 2030s. So I think it's one of these things that is right now, NASA is still vastly more capable than the Chinese Space Agency, but it's distracted. It's having its funding cut. Like it is not healthy right now. It is not operating on all of the cylinders that it can operate on, which is heartbreaking because NASA is the best. NASA is the greatest space exploration sort of culture and technology and just system that the world has ever seen. And it's being dismantled right now. And who knows what's going to survive, what's going to be left. So I think that there will be this sort of constant pressure coming from the Chinese, and that you will possibly see a resurgence of NASA, or you will just sort of see this slide towards smaller and smaller projects and less involvement over time. But right now it does feel like we're approaching this turning point for both nations. But like China has problems of its own. They have demographic issues. They have economic issues. I think people feel like China is like just this monolithic, inevitable success story, right? And they've got all kinds of problems that they're having to deal with. And so I think that we're going to find it's going to still be very interesting with a lot of players. It's a lot more vibrant. Europe has got a lot of stuff that's really interesting and happening. And like I said, the Indians have one of the most dynamic space exploration groups out there. They're able to talk about punching way above their weight. They produced a mission to Mars. They've got a lot of really interesting work and are they're planning their own space station and eventually to send humans to the moon. So I think it's just like, it's going to go from, back in the 70s, right? There was NASA and there was the Soviets. And now you've just got this sort of weird collection of all these different countries, private agencies within various countries. There's something like 70 rocket companies in China. You've got SpaceX, which is, developing a fully reusable two-stage rocket. So I don't think it's really easy to just give it this, like, US is going to win or China's going to win. It's going to look very different in a few decades from now. Minor downfall. Why is everybody hyped about Starship and nobody is hyped about Ariane 6? Well, Ariane 6 is cool. It's a new version of the Ariane series. It's got one more, right? It's the sixth. And they're developing a lot of new technology to make this rocket go. But it is still the old paradigm that there's no part of this that is a reusable rocket. Right now, SpaceX has been able to dramatically drop launch costs because they've really invested in this reusable technology. The Falcon 9 can be reused, more than a dozen times. Many of the different parts of the Falcon are reused. It's just the upper stage that is thrown away. And then as they're developing then the next generation, the Starship, you've got a fully reusable two-stage rocket. If they succeed, and it's still a big if. Right? We're not sure that this is going to work yet. Although, we saw really good signs with the Flight 11, where, we didn't see a lot of the heat damage that we saw in previous launches. So if they're able to make this work, then you're launching rockets for really just the cost of fuel and some servicing. That'll bring the cost down another probably order of magnitude. And so any rocket company that isn't investing in some level of reusable technology feels like they're just not going to be able to maintain competitiveness. Blue Origin, even though they don't really launch rockets, I can make a whole bunch of jokes about Blue Origin, but I won't. Their first stage is going to be reusable. So, Neutron is going to have a lot of reusability. So there's a lot of, and then in China, I mentioned, there's 75 rocket companies. Many of them are working on reusable rockets. We've seen reusable rocket tests And so it's really hard to compete in a market where people are undercutting your costs by half or by a third, right? And so, like, do you choose the Ariane rocket because that's the one that you have to choose because you're a European country launching a European mission? Or do you save half your launch costs and go with the Falcon 9, or save a tenth, save 90% of your launch costs and go with the Starship? So I think that's the problem is, whatever technological advancements they're developing with the Ariane 6, the fact that it's not reusable, the fact that they're not even in developing a reusable platform in any way, is the thing that people have the complaint with. Richard Louis Pierre, since looking out means looking back in time, isn't it possible that light from sentient worlds just hasn't reached us yet? Yeah, of course, but that just means that the universe is less sparsely populated, more sparsely populated than people had originally expected. And so if the nearest civilization from us, when you think about the kinds of impact that a really advanced civilization could have, like if they've had billions of years of technological advancement before we came along, they could have a very large impact on their galaxy. That's why people are always talking about looking for, say, type 3 civilizations where they're rearranging the stars in their galaxy, like the kinds of things that would seem very obvious. We would see stars covered in Dyson spheres, and then we would see an expanding group of Dyson spheres. That's the kind of stuff that you would expect to see really far away. We don't see any of that. We just see what looks like wilderness in all directions. So that would mean that if they're out there, then they're very far away. Robin Hanson, we talked about the Great Filter. He has also proposed the Grabby Aliens hypothesis and has calculated, he assumes that there will be some technological civilization is going to try to gather up as much space as it can. It's going to send its probes out at close to the speed of light and colonize star system after star system and make physical changes to the star systems in a way that is obvious to us as an observer. And so we would look out into the universe and we'd see, the way you would look across a landscape and see there's the place where the city is and there's the place where the forest is, the forest and the mountains. That's the nature. And then there's the city, which is the evidence of an advanced civilization. We look out into the universe and we see the space equivalent of the forest versus the cities. And the fact is that we don't. We just see forest when we look out, a dark forest. So we just see forests and mountains out in the universe, sort of hypothetically speaking, metaphorically speaking. And so then the question is, Hansen says that because these civilizations are going to be expanding at roughly the speed of light, like just shy of the speed of light, we won't see those civilizations until they sweep past us. Suddenly, before we saw wilderness, then boom, civilization. We're now in a city, in a space city. And that because we don't see them, you can use that to calculate how far away those civilizations are. And his point is that those civilizations are most likely tens of millions, if not hundreds of millions of light years away from us. So we're not going to see them for tens of millions, if not hundreds of millions of years before their civilizations sweep past us and start to fill up the universe. There's a great video on YouTube by Rational Animations talking about Grabby Aliens, and they just do a terrific job of explaining the process and sort of the thinking process. I have, issues with the Grabby Aliens hypothesis, but in general, I really sort of enjoy that as an explanation. I've also interviewed Robin Hanson, so if you want to sort of hear his take on it directly, if you just do a search on my channel, you'll find it's like an hour and a half long conversation with him, and he's great. Like he's a very funny guy, very quick, lots of ideas. Many I disagree with. People think I was a little hard on him, but anyway, yeah, check that out here on the channel. Trans Milkman, what astronomical event do you want to see the most? I want to see a bright comet. I rail about this all the time, but I really do. Actually, that's not the thing I would like to see the most. Like, I would like to see a bright comet. I've seen Hale-Bopp, Hyakutake back in the late 90s. They were amazing. I would like to see a meteor storm. Like, we've seen meteor showers, and I've seen strong meteor showers where you had maybe a couple of hundred meteors an hour during the Leonids one year. But in meteor storms, you're seeing sometimes tens of thousands of meteors an hour. It really looks like the sky is falling. Wouldn't that be amazing? I think the last time one happened was in the 60s. So they happen about once a century. And that's a thing I want to see, is a meteor storm. Visto, are you just trolling me now? Or the lack of a big bright. So Visto Tutti is the lack of a big bright comet proof of a malevolent deity. Yeah. I think that's the universe is trolling me then. The reason we haven't seen a bright comet is because some evil entity from across space and time really wants to make me suffer. American Loyalist, how long was the nothing before the Big Bang? We have no idea. We may never know. So this falls into that category of things. We're like, I don't know. Like, I know that's a really unsatisfying answer. It could have been anywhere between forever and zero time. Renbr, with China applying export controls for rare earths and rare earth magnets, are there any missions or projects that would be affected? That's an interesting question. I mean, from what I understand, the export controls from China are putting limitations on military stuff, but this would definitely fall under aerospace. So I would assume yes. This is a big problem for the United States that has no, there are some manufacturing, some of these rare earth elements and alloys and stuff. China has 100% control of it, and the whole world is sort of reliant on them. That sounds like a job for Canada. We've got lots of minerals. The problem is that producing those minerals cause a lot of pollution. They're often the byproduct of other very extractive methodologies of mining. And you have to use a lot of harsh chemicals to try and get at this stuff. And there aren't a lot of nations that are really interested in having that go on in their country, but China is okay with it. Hopefully people will be able to redevelop, other nations can start to ramp up manufacturing of these rare earth elements. Or we just stop having trade wars. We just get along again. Everyone just becomes friends. Yeah. Elliot Musso, what is your favorite LLM? I would say my favorite LLM is Claude. I've used it a lot for programming. I've become quite disillusioned, I guess, frustrated by how bad they are at doing a lot of other stuff. Just in general, LLMs, like for programming, it's very easy to know whether the thing works or doesn't work, right? You ask it to create some piece of disposable software, and it makes the software, and that's great. You can tell that it works. And as long as you don't put it into a production environment, don't use it for something that's really critical, it's probably okay. But the hallucination rate for these things is so high that they're unusable for doing research beyond a certain point. That the amount of, I'll give you an example. So I did I did the video about 3i Atlas, the sort of the overview, and, linked to about 20, 25 sources in that episode. And I didn't use a single LLM for that. Like I knew that I would spend more time trying to battle a hallucinating robot. So I just did it myself. Like I just went to archive, searched for 3i Atlas, looked at all the papers, and just started to build the outline of how I wanted that episode to go. It's too much work to try to convince a hallucinating robot that it's wrong. And then the writing style is really boring and very samey, with its M dashes, and that's not just this, it's that, and it's rules of three, and it's use of emoticons and all that kind of stuff. And so I think if you're good at what you do, then you currently dismiss it and you go, this is not helpful. There's stuff that it is, if I want to learn how to, if I need recipes, I guess they're good. But just like the day-to-day interactions with it, I've found it less and less exciting, which is super weird because you're literally having conversations with a piece of software, and you're like, yeah, I'm over this machine sentience. But yeah, I would say of all of them, the one that is the best is Claude, in my opinion. Pushes back. I even had it like, I forget the exact thing, but I was like talking to it about, I was trying to understand some topic, and I was sort of verifying my understanding of it, and it pushed back. It's like, I'm going to have to push back on you on this one. The way you're thinking about it is wrong. It's like this. I'm like, whoa, respect. Where's the sycophancy? Where's the, that's a game-changing idea that's not just going to help you understand the production of an ion tail, but could change physics forever. Nobel Prizes all around, Fraser. So, I appreciated that. So hopefully we'll get to this place where these large language models are less sycophantic, they don't hallucinate, and they write well. But then I'm out of a job. So just keep it up, robots. Was it clankers? Keep it up, clankers. Time for a couple of questions. Ian, if you could interview any astronaut or astronomer from history, who would it be and what would you ask? I would love to talk to Galileo. Like, I think that's the person. I don't know what I would ask him. But he was like the first person to take a telescope and really look to the sky and study all of the things that human beings had been examining with their eyeballs for thousands of years. I mean, if you look back to the Persian astronomers, the ancient Chinese astronomers, the various astronomers in Mesoamerican stuff, right? Like, they really understood the movements of the sky. When you think about Hipparchus, who was this ancient Greek astronomer, he used a sighting tube, like just a tube of metal that he looked through to be able to mark the positions of the stars. And he mapped like 700 stars in the sky and had positions, and had even tried to verify that the Earth went around the sun, because he was able to, he tried, but they couldn't measure the stellar parallax from the Earth well enough with his sighting tube. With better instruments, maybe would have figured it out. And then in the 1600s, 1610, Galileo turns a telescope on the sky for the first time. Like these rudimentary lenses had been used a little bit for battlefield. He's like, what if we point these things up and look at Jupiter or, you know, the moon or things like that? And when he did, everything changed, right? That it was just like suddenly he was seeing all these things in a way that nobody had ever seen them. And he saw them all. Like he didn't just see a new aspect of the moon that nobody had seen. He saw the new aspect of the moon, the rings of Saturn, Jupiter, the moons of Jupiter, how Venus goes through phases. He saw that the Milky Way was composed into stars and a lot of other stuff. And clearly just had this dramatic effect on his perspective of the universe. And he wouldn't shut up about it after that. So I would love to just have that conversation with what it was like to point that telescope in the sky for the first time and what happened. So yeah, that's by far, like this, you know, people always ask me this question, and that's the one that pops in my mind every time, because so many of our modern advances, he was the line in between the before times and the after times. Swallow Rick 1, will you be putting out a video on the 3rd year of James Webb discoveries? It's how I found your channel 2 years ago. I don't think so. We thought about it, like the 3rd anniversary of the James Webb would have happened in July-ish. And so we put out one in July 3 years ago, and then, or 2 years ago, and then July a year ago. And then we decided not to do one this year just because I think it's just like less. I mean, there's been a lot of discoveries, a lot of, you know, it's still going like crazy. But I think there's just a lot less interest. And so the thing that we're going to do now is we're going to do the same, but for Vera Rubin. And so Vera Rubin really comes online in November. And so we'll be keeping track of all of the discoveries made by Vera Rubin. Then I think we'll do the same kind of thing where we'll go like, here's everything we found in this last year, all of the, because it's like, there's going to be so much. Like we're not ready for what's about to happen, and we're like a month away from this happening. So yeah. Let's see. Okay. Sorry, just look at one more question. Karen 156. What calling card would you leave an early Earth-like world that would survive long enough for them to see? So the question you're kind of asking is, like, if we could go to another terrestrial planet around another star, could we leave something in that solar system that then when they became more technologically advanced, they could find it? And like, this is the plot of 2001, A Space Odyssey, right? Where humans find a monolith on the moon and it's been left there by aliens and tells us that you're not alone and then to not go to Europa. But so I think that logic, like, it's amazing that Arthur C. Clarke had these ideas. That was a very logical idea, that the best thing to do if you want to leave a message for another civilization that they might not be able to check for 1 billion years is to leave it in a place that isn't going to have erosion, and that's the moon. Now, obviously, the moon is getting pounded by micrometeorites, and so you leave several of them. And there are other places, like put something out into the asteroid belt, wherever your von Neumann factory was. And that, you know, even if you're, like, if you go to some other star system and you leave the monolith there and then they rise up and they, you know, because it's like, once you've gotten to the moon, if you've got the technological capability to get to the moon, then you're ready to contemplate the reality that there are other civilizations out there, that you're not alone in the universe. And so that's like a really clever idea. And so it's like really practical. It's a thing that we should definitely do. And I think, we should do that here in the solar system. Like, we could leave some kind of message, monolith, installation on the moon, in the asteroid belt, somewhere, that an advanced civilization follows us from the Earth. When the octopuses grow up, or whatever, the dolphins go to space, and then they'll find this and they'll learn about us. And it's a way that we can communicate with another civilization, not in distance, but through time into the future. And I really like that idea. It's very poetic to me. So I think that one of the things, and there are plans to do this already. There are lots of artifacts sitting on the moon right now, and people are planning like really tough, long-lasting, billion-plus-year installations that are obvious. They're on the moon, easy to find, easy to understand, and will tell some follow-on civilization that we were here, and this is what we were about, and this is what we have. This is our legacy to give you. And I like that idea. All right, we've reached the end of our 2 hours. So thank you, everyone, for hanging out with me today. Thanks in advance to Chad and Anton, who are going to have to edit this nonsense. Thanks to ZapFan and any other moderators who were here to help organize the comments and the questions. I really appreciate it. So much fun. I really look forward to this every week. Speaking of every week, so next week we're going to do this for the Australians. So it's going to be Sunday night at 10 p.m. my time, which is 4 o'clock, I think, in Australia, and similar times in Japan and China and so on. So I'll put a notification here on the channel for when the next event is going to happen, and hopefully we will see you then. Thanks, everyone, and we'll see you all next week. Sorry, Darth XO. Gold record. Agreed, except the gold record is just being sent randomly off into space, as opposed to putting something firmly on the moon where everyone can see it. All right. Farewell.